This is an introduction to the statistical vibration synthesizer system. The main screen contains 3 graphs, and located at top left of the screen are text windows for selecting the target functions, that is, the PSD and the RMS distribution function. These are labeled sheets, as these functions are defined and stored in Microsoft Excel spreadsheets. There is an active link between the SVS software and Microsoft Excel, so that all the target data that is used to define a test are handled within Excel. As is demonstrated here, the PSD sheet contains a number of pre-programmed PSD functions that can be selected by scrolling down the menu. As a PSD function is selected, it is displayed on the PSD graph located at top right of the screen. The same process is used to select a target RMS distribution function, which is automatically displayed on the RMS distribution graph located at bottom left of the screen. The use of an RMS distribution function is the main difference between the statistical vibration synthesizer and ordinary random vibration controllers. With the SVS system, we define a range of RMS levels at which random vibrations will be reproduced, instead of a single RMS level. An interesting consequence of generating non-stationary random vibrations, that is, vibrations with a varying RMS level, is that the statistical distribution or probability density function is no longer Gaussian. This non-Gaussian distribution can be calculated if each RMS level is assumed to be Gaussian. The PDF is shown on the graph located at bottom right of the screen. If we use the zoom facility, we can clearly see that the non-stationary random vibrations that we want to synthesize are non-Gaussian when compared with the equivalent Gaussian distribution shown here as a black line. In addition, the courtesy statistic is computed and displayed on the graph. The kurtosis of 5.58 confirms the non-Gaussian character of the vibrations. The PDF can be displayed on distorted scales, which makes it easier to visualize the non-Gaussian effect, as well as the presence of large magnitude events which are not present when Gaussian vibrations are synthesized. Once the target functions have been selected, the test parameters need to be configured. These are shown in a text window located at middle left of the screen. The parameters relate to fundamental quantities that need to be configured by the user. These include the test duration, the minimum segment length, which controls how rapidly the fluctuations in RMS level will occur, the feedback accelerometer sensitivity, and, when using the random vibration controller adapter module, the nominal RMS level of the RVC. Usually this is set at the overall RMS level, which in this case is 0.96. Only when this value is entered that the Start button, which controls the synthesis, appears. Now I will demonstrate various tools and facilities available within the SVS system. Focusing our attention on the menu items on the top line of the screen, under the File menu, we can use the Open function to upload the target libraries. We have access to additional software modules such as the Field Data Analysis module, the Vehicle Trip Synthesizer module, and the SVS File Viewer module. The functionality of these modules are explained in separate demonstrations available from the website. There is also an option to continuously record the synthesized vibrations measured by the feedback sensor. This can be useful for reporting purposes and for further analysis. Under the Display menu, we can activate a number of features. These include an oscilloscope display of the synthesized vibrations as measured by the feedback sensor, the RMS overlay which plots a time history of the RMS level, the RMS histogram, which controls an active display of the RMS fluctuations, the PSD tolerance controls the appearance of tolerance plots on the PSD graph. Finally, the continuous updating of a kurtosis statistic can be activated. Under the Parameters menu, there are 3 levels for configuration of a system and test parameters. First are the operator parameters, which include the feedback sensor units, the feedback sensor default sensitivity, the feedback sensor type. The hardware module contains the necessary circuit to enable direct connection with ICP type sensors. The default PSD or spectral resolution, the minimum segment duration, which controls how quickly the random fluctuations in RMS level occur. When the RVC adapter module is used, there is a facility to automatically pause the statistical vibration synthesizer system when the RVC is stopped. Real-time digital filters that can be applied to the measured signals. The crest factor, or sometimes known as a sigma clip factor, which limits the maximum magnitude of each Gaussian segment. And finally, the default test duration. The advanced and administrator parameter menus are explained in detail in the help files. All the parameters can be saved as defaults. Also, the screen layout can be controlled. That is, the location of every text window and graph can be defined by the user and saved. Finally, we have a help menu that gives the user access to well-documented information on how to use a statistical vibration synthesizer system. It contains a series of topic-related menus. For example, if we select Product Overview, the software launches Internet Explorer to display the help file and allows the user to search for specific information. In addition, the system contains a number of context menus that can be accessed via the right mouse key from various locations across the system. For example, if I locate the mouse on the PSD graph and use the right mouse key, a small pop-up window appears that includes a link to the relevant help file. I can repeat this for the RMS distribution, and the help file for the RMS distribution is displayed. This concludes the introductory tour of a statistical vibration synthesizer system.